Oh, sorry for the delay, but my wife wanted me to make her some popcorn, so I had to go downstairs and make some popcorn. We always make it on the stove in a pan with oil. It's the only way to go. This is section 3, which is, again, what I call linear combination, the combining of lines. The book, I think, calls it addition or subtraction, but sometimes you don't. Sometimes you have to do other stuff as well. So anyway, linear combination is one I use. This right here is a pretty straightforward one, and the whole idea is, before we were substituting one equation portion into the variable in the other. We were combining them together using that substitution. Here, what we're doing is we're combining the two equations together, again for the purpose of eliminating a variable. And sometimes that works out really nicely if we just add them together. If you look at this first equation right here, you can see that if you add the, and by the way, you really need these in standard form. I noticed that one of the homework problems, things weren't organized quite right. They've got to have variable, the first variable lined up, the second variable lined up, the plain number lined up, the equal signs lined up. If this were x equals 2y plus 10, it wouldn't work. You've got to have them all lined up, the first variable, the second variable, and the equal sign. So you see right here with these lined up, if you were just to add these together, what is x combined with a negative x? Well, they cancel out. Your variable is gone. Again, doesn't always work out. If you look at this right here, do you see these canceling out? No, we'll have to do some other stuff here. But this right here, oh, just add them together. Those cancel, and when we add the 2y plus the 3y, we get 5y. When we add the 10 plus the 5, we get 15. Divide both sides by 5, we get y equals 3. Now, the unfortunate part about this is there's no convenient place to substitute that back in. That's fine, we just have to substitute that in, all right? So pick one of the equations. I like to pick the equation that has smaller numbers, but more importantly, no negatives if I can get away with it. So this equation right here, the first one, x plus 2y equals 10. And I just put what I found for y right in for y. So I've got x plus 6 equals 10. Subtracting 6, what plus 6 equals 10? Subtract 6 from both sides, you see x equals 4. So I know my solution then is the point xy, 4, 3. So that's how you do this linear combination method. If you look at this one right here, again, if I were to add these together, I would get 11x minus y equals 26. That's not helpful. I didn't get rid of a variable. So I've got to figure out a way, well, how do I make them line up? Like this, these were the same numbers in front. They were both ones, one positive, one negative. The y's at least are one positive, one negative, right? So if I can think, what if I built these equations up? What if I multiplied the equations, both sides, by a number, so that I could work them together? In other words, if you think common denominators, if we had 1/4 plus 1/5, we'd add those together by getting a common denominator of 20. If I were to multiply this top equation, by 5, every part of it by 5, wouldn't that give me a 20y? If I multiplied this bottom equation by 4, wouldn't that give me a negative 20y? Right? Now I've got a system of equations that cancels. So 5 times 7 is 35x plus 20y equals negative 10. And 4 times 4 is 16x. 4 times a minus 5 is minus 20y equals 80, 8, 9, 10, 11, 11, 2, 112. Oh man, these numbers can get pretty large, right? But now you can see that if I add these together right here, those cancel right out. And now I just have to figure out what all this mess is. Looks like 40 plus 51 equals 112 minus 10 is at 102. Oh, nice. That works out beautifully. Divide both sides by 51, and I get x equals 2. So if x equals 2, now I just pick one of those other equations. I think I'll do the top one. 7x plus 4y equals -2. What did we find for x? 2. So that's going to be 14 plus 4y equals -2. If I subtract 14 from both sides, I think that's going to give me 4y equals -16. You can just barely see that. If I divide both sides by 4, that gives me y equals a -4. So my solution then is going to be the point 2, -4. Not a whole lot of word problems in this section. I think we'll save that for section 4. So stay tuned for that one. That's going to be a fun one. See ya.